Hey guys, this is Megan again, and welcome back to the OnlineMathCircle AIME video tutorial series. And today we are going to discuss 2009 AIME I problem number 2. There is a complex number z with imaginary part 164 and a positive integer n, such that z divided by the quantity z plus n is equal to 4i. Find n. Now, the complex number z must include both a real part a and an imaginary part bi. So let z equal a plus bi. So we want to find a positive integer n such that z divided by z plus n is equal to 4i. So in order to do this, since we already defined z as a plus bi, we can simply just go ahead and substitute it in to the given equation. So we have a plus bi all over a plus bi plus n equal to 4i. So we are given here that the complex number z has imaginary part 164. And the imaginary part in this case is b, so b is equal to 164. So we can just plug in b as 164 in our equation, and that gives us a plus 164i all over a plus 164i plus the integer n equal to 4i. And we know that a and n are both real numbers, so they consist of the real part of the complex number a plus n plus 164i. So we can rearrange those terms just for clarity. And then we get a plus n plus 164i on the denominator. Now, in order to solve for a and n, we must multiply both sides of this equation by a plus n plus 164i. That way we can get rid of the fraction. Doing so gives us a plus 164i equal to 4i times a plus n plus 164i. And once we have that, we have a plus 164i equal to 4 times a plus n times I plus 4 times 164 times I squared. Since we know that I is defined as the square root of -1 in terms of the definition for imaginary numbers, I squared is equal to -1. So the real part of this complex number must equal the real part of this complex number. So that means a must be equal to 4 times 164 times I squared. 4 times 164 times I squared is obviously equal to -4 times 164, and multiplying that, we get -656. And that must equal a. So a is equal to -656. And now we want to move on to equating the imaginary parts. So doing that gives us 164 equal to 4 times a plus n. And by plugging in a equal to -656, we get 164 equal to 4 times the quantity -656 plus n. And dividing both sides by 4, we'll get 41 equal to -656 plus n. And adding 656 to both sides of the equation, we get n equal to 656 plus 41, which is 697. And that is our answer.